Hello everyone and welcome to another Maths tutorial video. Today I'm going to discuss Form 5 Additional Mathematics Chapter 3 Integration Long Question Part 1. Before I begin, if you are new to any of my videos, please do subscribe to my channel and hit the notification bell as I will be discussing more mathematics tutorial videos in the future. Alright guys, without further delay, let's jump to the question now. Okay, by the way guys, in this video I'm going to discuss two integration questions. You are now looking at the example 1. I'm going to read the question now. The gradient function of a curve is kx squared minus 6x, where k is a constant. Given that the straight line y minus 9x plus 5 is the tangent to the curve at the point -1, -9. So the question asks to find the value of k and the equation of the curve. Alright guys, I hope you will attempt this question in the future. If you could manage to solve this question, well done guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. Alright, let's proceed to show the solution now. Okay, this is the solution for question part A. Okay, given the gradient function of a curve is dy dx equals to kx squared minus 6x, and in the question they've already given us the straight line y minus 9x plus 5 is the tangent to the curve of the point -1, -9. So as we learned in the differentiation, the tangent to the curve is also considered a differentiation guys. So how are we going to find the differentiation value from y minus 9x plus 5. So it's very simple. When we bring negative 9x plus 5 to the right hand side, it will become y equals to 9x minus 5. So this 9, as we learned in the straight line form, which is in the y equals to mx plus c. So this is actually a m. M is actually a gradient of the graph. In this case, our straight line y equals to 9x minus 5 is the tangent. So the gradient of the tangent is a 9. So what we're going to do now is we're going to relate this 9 value to the dy dx. Sound confusing? No worries guys, I'm going to show you the step-by-step working now. So please stay with me. Okay, for the first step, what we're going to do is we're going to compare the gradient of the graph value. So which is the gradient of the graph? They already gave us the kx squared minus 6x. And then what we're going to do is we're going to compare with the gradient of the tangent. So it's given that y minus 9x plus 5 is equal to 0. Okay, what we're doing now is we bring everything to the right hand side, so it becomes y equals to 9x minus 5. As I said earlier, this 9 is the gradient of the tangent value. Okay, what I'm going to do now is I'm going to compare this gradient of tangent value to the gradient function of a curve by using the coordinate -1, -9. So please take note guys, you only have to use the x coordinate value. You don't need to use the y coordinate value, because we are calculating with respect to dy dx. We are not calculating with respect to y. This is our y value. This is the x value which we will be substituting into this dy dx. Okay, let us continue. So kx squared minus 6x equals to 9. So we're going to substitute the x in the equals to -1. So from here we get k in the bracket -1 square minus 6 in the bracket -1 equals to 9. So -1 square you get is +1. So k plus 6, -6 times -1 you get +6. So k plus 6 equals to 9. K plus 6 equals to 9. So what you do is you bring the you bring this +6 to the right hand side. So it will become k equals to 9 minus 6. So from here, you will get your k is equals to 3. Alright guys, we have already solved our part A solution. Now let us proceed with the part B solution. Okay, please hold on. Okay, in the part B, Since in our part A, we have already found our k value, so what we can do is we can immediately substitute our value k is equals to 3. So now our dy dx value is equals to 3x squared minus 6x. So since the question asked to find the equation of the curve, so how are we going to find the equation of the curve? Alright guys, we are going to integrate this dy dx. So how are we going to integrate this dy dx? Okay, I'm going to show you now. The first of all, we need to times the whole equation by dx. So this dx will be in a fraction form, will be cancelled out, and in the right side will be times by dx. So dy is equals to, in a bracket, 3x squared minus 6x with respect to dx. So let us continue. Step 1, we are going to integrate y with respect to dx. So this is in the dy form. So when you change this into y form, you need to integrate the right hand side of the equation. So y is equals to integrate of 3x squared minus 6x with respect to dx. Let us proceed to the next step. Okay, when you integrate this, you should be getting your answer y is equals to 3x cubed over 3, because you're adding your power, x to the power of 2, you add plus 1, so it becomes x cubed, and this 2 plus 1 you have to divide as well. So 3x cubed divided by 3 minus 6x squared over 2, so this x was in the power of 1. So when you integrate, you need to add 1, so it becomes 6x squared. So that 2 you need to divide as well, 6x squared divided by 2. And don't forget to add a c guys. C is a constant since we are dealing with the indefinite integral. Okay, so we have y equals to x cubed minus 3x squared plus c. But this is not the final answer guys, we still need to find the value of c, the constant value. So how are we going to find the value of c? Alright guys, I hope you remember that in the earlier of the question they have already gave us the coordinate x and y. So what we're going to do now is we're going to use those respective x and y coordinate values, and we're going to substitute inside this equation and then to find the respective c value. Okay, let us continue. So we're going to use the point -1, -9. So -1 is your x coordinate and -9 is your y coordinate. So -9 equals to -1 cubed minus 3 -1 square plus with c. So from here, let us continue. So -1 cubed, you should be getting -1. -1 square, you should be getting +1. But then you times with -3, you still get -3. So -1 minus -3, you should be getting -4. So -9 equals to -1 minus -3, you should get -4. And then your c, you should be getting your answer is -5. Alright guys, we have almost close to our final answer. Therefore, the equation of our curve is y is equals to x cubed minus 3x squared minus 5. So this is your final answer guys. Alright guys, I've already completed my first question of integration. Now I'm going to proceed with the second question. Okay, please hold on for a moment. Okay, let's read the example 2 question together. The gradient function of a curve is 3x squared plus x minus 2. Given that the curve passed through the point 2, 5, the question asks to find A, the equation of the curve, B, the coordinates of the turning point of the curve, and determine whether each turning point is a maximum or minimum point. Alright guys, let us proceed to the solution now. Okay, the first question, part A, they asked to find us the equation of the curve, and they've already gave us the gradient of the curve, which is the dy dx. By the way guys, the gradient function of the curve is also known as dy dx. Please take a note of that. So they already give us dy dx equals to 3x squared plus x minus 2. Okay, what we're going to do to find the equation of the curve? Yes guys, you are correct. We need to integrate this value. So we bring the dx over here, or you can times the whole equation by dx, is up to you. dy is equals to excuse me guys, in a bracket 3x squared plus x minus 2 with respect to dx. So we're going to integrate y with respect to dx. So what we do is we integrate 3x squared plus x minus 2 with respect to dx. Let us proceed. So from here, y is equals to 3x cubed over 3 plus x squared over 2 minus 2x plus c. So don't forget to add a c guys, since we are dealing with the indefinite integral over here. So these 3 and 3 will cancel off. Okay, let us proceed. But this is not the final answer guys. As I said in the example 1, we still have the c value. So we're going to use the respective point to calculate the c value. So how are we going to do that? Okay, let me show you the working now. So 2 is the x coordinate, 5 is the y coordinate. So I'm going to substitute the 5 as a y and 2 in the x. 5 equals to 2 cubed, which is 8, plus 2 square over 2, which is 4 divided by 2, which you get back is 2. And then minus with 4. 2 times 2 is 4 plus c. So 5 equals to 8 plus 2 minus 4 plus c. So you should be getting your c is equals to negative 1. So 8 plus 2 you get is 10. 10 minus 4 is 6. So 5 minus with 6 you get back is negative 1. So from here you get the equation of the curve is y equals to x cubed plus x squared over 2 minus 2x and minus 1. So don't forget to rewrite the whole equation guys. If you don't write this, you might lose your marks. Okay, we have already solved the part A question. Let us proceed to the part B now. Okay, for the part B, they ask us to find the coordinate of the turning point, and then they ask us to determine whether each coordinate of the turning point is a maximum point or minimum point. So what is a turning point guys? So this is the basic explanation I get to show to you. As you can see here, this is a curve and this is your tangent. Just assume this is a tangent, this is your curve. So when your curve and this is your tangent, and when your tangent is in the horizontal form, you can assume this is your dy dx is equals to 0, because makes sense guys, because this straight line has no gradient. Your gradient is 0, it's a flat line. So this is your dy dx equals to 0. When your dy dx is 0, it's believed that this is your turning point. Your turning point meets when your dy dx equals to 0. Alright guys, this is the basic explanation. Okay, for step 1, to find dy dx, to find the turning point, we need to set our dy dx equals to 0, because from this diagram, the turning point is the exact point when your dy dx is exactly equals to 0. So for that, we need to set our dy dx is equals to 0. In the question, is given that dy dx is equals to 3x squared plus x minus 2. So when it's set it equals to 0, now if you notice here, you have already formed a quadratic equation. Let us proceed to the next step. So when you factor this out, you should be getting 3x minus 2 and x plus 1 equals to 0. From here, you get two x values, guys. The first x value is x equals to 2 over 3 and x equals to negative 1. Okay, guys, we have already successfully do of step 1. Let us proceed to the step 2. Okay, once you've already find the turning point and you set your dy dx equals to 0, and you found the respective x value, so what you're going to do now? So step 2 is you need to do the double differentiation. Okay, double differentiation, why we are doing this is to find that whether the particular x coordinate, the point is a maximum point or minimum point, guys. Okay, but in this case our dy dx is 3x squared plus x minus 2. So when you do double differentiation, which is d squared y over dx squared, you should be getting 6x plus 1. So you bring the the 2 times 3, you times, and then the power you minus by 1. So this x will become 1. So this minus 2, since it is a constant, so it will be removed away. So d square y over dx square you get is 6x plus 1. So what we're going to do now is we're going to substitute each x value and we're going to determine whether the x value gives us a maximum value or minimum value. Okay. Substitute the respective x values. So we're going to start with d square y over dx square. We're going to substitute 2 over 3. So when x equals to 2 over 3, so 6 times 2 over 3 plus 1. So where you get your d square y over dx square is equals to 5. Alright guys, I'm going to tell you a small explanation. When you get your d square y or dx square into a positive value, that means that particular turning point indicates that it's a minimum point. So since give us a positive value, remember this, positive value always give you the minimum point. So in this case, d square y or dx square is equals to 5. This coordinate gives us a minimum point. Let us proceed for the next x value. So when x equals to negative 1, d square y or dx square equals to 6 in the bracket negative 1 plus 1. So from here you get your d square x or dx square equals to negative 5. Alright guys, since this is in the negative value, so this point where your x equals to negative 1 give you a maximum point. Alright guys, you already know this is the 2 over 3 gives you a minimum point and negative 1 gives you a maximum point. So now we need to find the respective y value. So what we're going to do now is we're going to use this x coordinate and then we need to substitute back into the original equation of the curve to find the respective y coordinates. So let us proceed to the next step. Substitute back the x value to the equation of the curve to find the y value. So that is our step 3 guys, respectively. So when x equals to 2 over 3, so y is equals to 2 over 3 square, 2 over 3 cube plus 2 over 3 square over 2 minus 2 times with 2 over 3 minus 1. So from here you get your y is equals to negative 49 over 27. So therefore you should know that 2 over 3 comma negative 49 over 27 gives you a minimum point. Okay, let us proceed for the second x value. So when x equals to negative 1, you substitute back the negative 1 value. Y equals to negative 1 cube plus negative 1 square over 2 minus 2 times with negative 1 minus 1. So from here you get your y value is 1 over 2. So therefore negative 1 comma 1 over 2 gives us the maximum point. Alright guys, that is all for my step-by-step working and solution for this question. Any questions or feedback, feel free to put in the comment section below. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please do click the subscribe button and hit the bell icon as well. Thank you for your support guys, and I will see you in the next video.